Folks, welcome back to Chapter 2 on Linear Programming or Unit 2. Refer to the problem 2.4 that I have on my problem data set, or it could be a problem in your book as well. Okay, but nonetheless it's there in the problem data set that I have uploaded on the Blackboard. Now, in this is a straightforward problem, very simple problem. This says the following table summarizes the key factors about two products, A and B, and the resources Q, R, and S required to produce those. Then you have the table there, resource Q, R, S, then product A and B. Now against Q under product A it says 2. What that means is it requires 2 units of resource A to produce each unit of A. That means each unit of A consumes 2 units of resource Q, and product B consumes 1 unit of resource Q. The total amount available of resource Q is 2 units. Okay. Then profit per unit, the last row says product A, each unit gets you $3,000 in profit, product B $2,000 in profit. Let's just formulate this as a spreadsheet model and solve it. Okay. So the first thing is the decision. Decision is how many units of product A and product B to produce. So create a column for product A and a product B, and of course a row unit produced, and this is our decision. Let's always highlight that in yellow color. Okay, then underneath that, for product A, all the pertinent relevant of information should be represented there, and for product B, same thing. Unit profit is $3,000 for product A and $2,000 for product B. Resource usage, Q, each unit of A takes 2 units of Q, and each B requires 1. Whereas the resource R, each unit of A consumes 1 unit of R, B takes 2 units, and likewise for S, 3 and 3 each. So this is the amount that's available. And now when we make 1 unit each, let's say 1 unit each, then we know that we produce 1 unit each of this one. So that means our profit should be 3,000 times 1, 2,000 times 1, altogether 3,000 plus 2,000, that is 5,000. So this is something that is computed. Okay, not a decision, but a consequence of the decision. So let me just go and select a color scheme, something like that, for anything that gets computed. Now over here, the total used. That means the resources that we have Q, R, and S available is 2, 2, and 4. How many units would we use if you produce 1 unit of A and 1 unit of B? So 2 times 1 plus 1 times 1. So together we will use 3 units. So that's what gets consumed over here. Again, this is a consequence of the decision. So let's just go and use this color scheme there. That's what gets consumed, okay? A result of the decision. Now, let me just go and then blank these two. So what I want to do here is just the way that the number of units times the production level times the contribution plus the production level times the contribution gives us the total profit. So what we did was we took the product of these two individually, then added them up. So the command that we want to use is sum product, the number of units that we produced, times what is the unit contribution to the profit. So what it does is it takes D5 times D7, then E5 times E7. Those are the products it takes. Then it adds them up. Then it sums it up. That is sum product. Okay. Naturally, we are not producing anything, so it should be 0. Now, the amount that we use of this resource again depends upon our production activity here. If you produce 1 unit each, 2 plus 1 is 3 is what we use. If you produce 2 and 1, 2 times 2, 4 plus 1 is 5. Okay, so that's how much we would be consuming. So again, the amount of R that we use still depends upon the amount of quantities that we produce of A and B. So it still is the same thing. Yes, the amount that we use is still the amount that we produce times the individual usage rate. So this is common, okay? That is common when we compute the usage for all these three resources, because resource usage depends on the activity level. That's the reason, okay? So some product, since I'll be copying my copy and paste, and this is common for all three constraints, I'm going to highlight that and hit the key F4. When you hit the key F4, or precede them with a dollar sign. So when you precede them with a dollar sign, what it does is it fixes their location, or the reference is absolute. Okay. Comma. Now the Q. What it does is it takes the product of D5 and D10 plus E5 and E10 and writes that combination, this resulting value there. Now go to the southeast corner, copy the command down. Okay, whenever you copy the command down, go to any one of these places where you copied the formula, double click that cell, then it gives you what the formula contains. So here the amount of resource use that we use, okay, depends on the production quantity that we make times the contribution rates or individual rates. That is correct. Okay. Now we have set up the spreadsheet model here. Okay, so now here we have the columns for the decision variables, and we have the relevant data for each one of those products there. Then we have built the relationship. The total profit depends upon the amount that you produce, that is the quantity level times their individual profit, contributions. And likewise, the amount of resource that you use depends on the activity level and in the individual usage rates. Okay, we have done that. Now what we want to do is we want to find out, since it's a profit maximization, we want to find out what is the maximum quantity that we can produce of A and B that will get us the most profit, okay, most profit, while the resource that we use stays within what is available. Okay, so that's the optimization. So for this, I'm going to go under data, then I'm going to look for solver. Okay, solver. If you don't see the solver under the data, what I would like you to do is your Excel has a solver, but it is not perhaps so the Excel has a solver. If you don't see it there, it's not yet activated, so you need to activate that. Now go to this place, look at where the cursor is, then go to the Excel options. Under the Excel options, click the add-ins. When you click the add-ins, so then you basically see what you need to add. Okay, Excel add-ins, you can click on that, then go to OK. Then the solver should be there. Okay, once you do that, then go back to the data, click on data, then you'll see solver under there. Okay, now that's my active cell, total profit. Click on solver. So what we want to do is, the default is always max. So this is my target cell. My target cell is, what is my target? My target is to maximize the profit. So that's my target cell. And I want to maximize, so leave that there. Okay, that's the default. Changing cells is what drives the profit. What drives the profit is the amount of quantity that you produce. So these are the changing cells, or my decision cells. Okay, so that's what drives. Now, can I keep on making infinite profit by making infinite products? No, I cannot, because why? I have this resource restrictions here, the amount that's available. So that's where the constraints are. This is where we need to send this information right there. Click on add. Okay, now the left side is this part. Okay, The right side is this part of the constraint, the right hand side of the constraint. Now in between the left and the right is the relationship that you see. That's the relationship that we have. Okay. Now this is less than or equal to, this is equal to, greater than or equal to. INT means integer values, so decision variables can take only integer values. And BIN means binary values. The integers can take only binary value, which is 0 and 1. Now in our case, all three constraints are less than or equal to. So what we could do then is we can, in this cell reference, instead of passing them individually, we can pass this information collectively like that. Give that range. Okay. Then on the right hand side, leave this box as it is because default is less than or equal to. That's what we have. Go and click that. So the ranges are the same. That three values in the column, 3 values in the column. Now we don't have any more constraints. That ends it. So click OK. Okay, now click on Options. Under the Options, assume linear model. Don't do anything with this. Leave them as they are. Assume linear model. Yes, the relationship is linear. If I produce 1 unit each, I make $5,000 in profit. If I produce 2,000 units each, 2 times 3,000 plus 2 times 2,000. So that's a linear relationship. Likewise, the resource usage again is linear. So click on that, assume linear. Assume non-negative. So whether I produce, then it's going to be positive quantity, or I don't produce, in that case it is 0. It cannot be negative. So click on that one and you are done with it. Click OK. Click Solve. Now it tells you solver found a solution. Okay, so it has found a solution, meaning that the amount of resource that we use is less than or equal to what's available. Okay, what it calls for is to make 0.67 units of A, 0.67 units of B, for a total profit of 33. The resource that you use, Q, 2 units is used, and what is available is 2, so 2 equals 2, so that satisfies that. Here it is 2 equals 2, that's how much we used. 4 is what's available, 4 is what we used. Okay, so that's what that all constraints and optimality conditions are satisfied, means the left side values are less than or equal to, the relationship basically holds with respect to the right side values. Click OK, and that solves the linear programming problem.